Okay. So if one person is presenting it, whenever it is needed, you can unmute and you can talk to the corresponding person, or otherwise we can talk to us also, no problem. But don't interrupt. Other than that, please mute yourself, okay, during the whole session. Whenever it is needed, you can use unmute and talk. Okay. Shall we start? Participants?
Yes, sir.
Yeah. So the first presentee, Silvarani. Silvarani, ma'am, are you there in the list? Silvarani, ma'am. Okay, so far Silvarani ma'am has not joined so far. We will wait for her. And then the next person is Niranjana N. Niranjana N.
Yes, sir.
Yeah, you can start to present your presentation. Paper ID 637. So the title
Yes,
is,
sir.
title is Free Convection Oscillatory Flow through porous medium in a rotating vertical plate in the presence of radiation heat source and the transverse magnetic field. Okay,
Yes, sir.
yeah, so to start to present your screen and then present your
Sir,
presentation.
is my screen is visible, sir?
No. Try to start one more time. It's not visible so far.
Okay, sir. I just share my screen. That's why I'm asking, sir.
It's the down right side down. Present now option is there in the Google Meet. So click it
Yes,
first,
sir.
and then
Okay, sir. Okay, sir.
present entire screen so that it will.
Now is it okay, sir?
No, it's not still outside as well. Yeah, now it's coming. Started coming.
Okay, sir. Good afternoon to all present here.
One.
Sanjana, and
No. Still
yes, sir.
your
This is
video.
my title.
Yeah. Yeah, fine. Go ahead.
Okay. This is my convection oscillatory flow to porous medium in a rotating vertical plate in the presence of radiation, heat source, and transverse magnetic field. And this is my abstract. Actually, I would theoretical analysis of effects of permeability and the injection suction on an oscillatory free convection flow of a viscous incompressible fluid through porous medium bounded between infinite vertical porous plates presented here. Heat absorption and chemical reaction effects with heat source are all added into the governing equation, and then detailed computation of the influence of some non-dimensional parameters like Hartmann number, heat source parameter, slip parameter, Peclet number, and some parameters are discussed over here. And here my formation, here I can consider a Cartesian coordinate system where x-axis lie along the center of the channel and y-axis is the distance measured in the normal section is chosen as the origin plate, which is moving with a constant velocity, and uniform transverse magnetic field with the strength is applied parallel to the y-axis. And then this is my governing equations along with the boundary conditions, and then the some of the parameters with the explanation which I used over here, and then the reduced form of my governing equation is shown in this figure with the non-dimensional parameters terms which we used for the problem, along with the boundary condition and the notations which we used like nomenclature. The method of solution, here I used to solve the Petribution technique to solve the problem, and then we can due to the oscillatory flow we can consider the terms to solve this problem, and then this is the final solution of my problem. I'll get the solution for velocity, temperature, and the concentration profiles of this problem, and then the skin friction, rate of heat transfer, and mass transfer are all shown here. And now I will move on to my results and discussion. I will try to put some graphs for velocity, temperature, and concentration profiles. Here, first I would like to show my temperature profile for the radiation parameter. Here, the radiation parameter increases while the temperature profile decreases. And then the temperature profile for the Peclet number. Here also the same concept. The temperature profile decreases due to the increasing in the parameter. And here you can see the explanation. The radiation parameter N is a relative contribution to the heat transfer of thermal radiation transfer. Actually, the temperature profile decreases when there is an increasing in the radiation parameter N. And similarly, in the Peclet number, the effect increase the value of Peclet number results in decreasing in the temperature profile. Actually, in both cases, the temperature profile decreases in both figures. And then now I would like to show my concentration profile. Here, the concentration profile for Schmidt number. Here also the same result I got. That Schmidt number reduces. Schmidt number increases when the concentration profile decreases. Next, for a chemical reaction parameter, also I got the same result. When the chemical reaction increases, the concentration profile decreases. And then the concentration profile for radiation parameter. Here you can see the explanation for that. The influence of a Schmidt number on the concentration profile are plotted in the figure 2A. That is in the first figure of concentration profile. It is the concentration profile decreases when the Schmidt number increases, and in the next chemical reaction parameter decreases in the concentration profile. The same effect is also in the suction parameter also. So again, in concentration profile, the three parameters having the decreasing condition. And then now I move to here the velocity profile for the number. Here the profile decreases while the parameter values are increasing. And now you can see the Gresh number. Here the increasing both like the velocity profile as well as the Grashof number, both are increasing status. In the mass transfer, Grashof number for mass transfer. Here also we can see the increasing cadre only. And then now the magnetic parameter. Obviously, we know that the velocity profile decreases when the magnetic number increases due to the Lorentz force. And then the Darcy number, we can get the increasing case and the same, both increasing. And then Schmidt number, again we get a reverse trend. The Schmidt number increases, the velocity profile decreases. And then the chemical reaction parameter also having the same property. Here I just conclude what are the things I have explained over the figure related to that place. So now I conclude my session. That is, my conclusion is that the following results on the velocity, temperature, and concentration distributions for various parameters. Also, and the coefficient of skin friction at the wall is also discussed. Here, in the velocity profile, the fluid increases due to an increase in the Grashof number, mass Grashof number, Darcy number, chemical reaction parameter, and suction parameter. In all these parameters, my graph shows the result that the velocity profile increases. And in the another case, the velocity profile of the fluid decreases as the Hartmann number, Peclet number, and Schmidt number increases. In this three parameters, it shows an decreasing cadre. And then now the fluid temperature decreases due to an increasing in the radiation parameter and Peclet number. The fluid concentration also decreases due to increase in the Schmidt number, Peclet number, and suction parameter. The skin friction coefficient at wall increases due to an increasing of Darcy number, suction, and Schmidt number under chemical reaction. The skin friction coefficient at the wall decreases in the increasing of Grashof, Hartmann, and magnetic parameters. Here are my references which I have useful for me to create this paper. So shall I continue in next paper also?
Yeah. Wait. Any doubts, participants? Any doubts or queries? No doubt, co-chair.
No, sir, it's okay. But the only thing I want to mention that participant, can you go to that your graphs? Niranjana, can you go to that graphs in your presentation, presented graphs?
Sir.
Yeah. In all graphs, I can see that you have presented the values with respect to some y. What this y represents actually?
So Y belongs to the axis which fixed the one boundary used to this problem, sir.
Okay. Okay. Thank you.
X-axis denotes the boundary condition,
Yes.
and the Y-axis denotes the profile, that is the solution.
Okay. Okay. Thank you. No other questions, sir. Okay.
Okay.
Okay, sir. Okay. Thank you, sir.
Niranjana, what is the characteristics of Peclet number? The definition are Peclet number. You have used in your problem. Peclet number.
What is a Fibonacci
1 minute.
graph in ours? A Fibonacci graph is a graph whose degree sequence consists of consecutive
Just for interrupt, sorry for the interruption.
The Peclet
Prakash, are you here? Prakash and Sovi, can you?
Yes, sir. We are both are here, sir.
Prakash?
We are both are here.
Okay. How many talks are? Is it the first talk in our session?
Sir. First talk.
Yes, sir.
Selvarani ma'am is waiting actually.
Okay. Please continue. Carry on.
Okay,
Okay, sir. Okay.
Okay. Carry on. Thank you.
Okay.
Sir.
Yeah. Peclet number.
Yeah.
Do you know that?
Yes, sir.
Oh, perfect.
Great. Yes, sir.
Yeah.
Sudden then cross-talk, I was forgot that.
Okay.
Yes, sir.
So those things, at least actually, that whatever we are putting in the dimensionless parameters, so those things at least try to know the characteristics, names, and what it shows, and what is the use of in related with fluid. Those things try to memory. Always keep in your mind, since we are
Sure,
all
sir.
fluid and make people. Okay. In future. Okay. You can start
Sure,
with
sir,
the next work.
Okay, sir. Actually, this is my 1 minute, sir. This is my second paper, and the paper ID is 210 and 638. The oscillatory flow of a second-order fluid through porous medium in a rotating vertical channel with a chemical reaction and heat source. This is a second-order fluid. So, a general exact solution of the partial differential equations governing the flow problems is obtained by adding the chemical reaction and heat source. The analytical results are numerically analyzed and then graphically presented to explore the effects of various problems, parameters, and the significant details. And then here I can show the formation of my problem. The flow of a second-order viscoelastic, incompressible, and electrically conducting fluid through a porous medium bounded by two infinite vertical parallel porous plates is studied using an oscillatory magneto-hydrodynamic convection flow model. Constant injection and suction velocities are applied to the two porous plates with the slip flow, and there is no slip condition. The pressure gradient in the channel varies with the time on a regular basis. A uniform strong magnetic field is applied in the direction perpendicular to the plate planes. Due to the presumption of a small magnetic Reynolds number and the induced magnetic field is ignored here. The temperature of the no-slip plate is non-uniform and oscillatory constantly with the time, and the temperature difference between the two plates is presumed to be large enough to cause the hard radiation. The entire system revolves around an axis that runs parallel to the planes. A closed form solution to the problem is obtained using the complex variable notations. Here, my geometrical figure, and then the method of solution. I just directly quoted the governing equations only with the boundary condition, and my solution. this is my graph. I got two graphs only for this problem. Also, I would like to work more on it. This is my velocity profile for the slip flow parameter. The velocity profile with increasing the slip flow parameter, quite obviously from the figure that velocity goes increasing with the increasing parameter. Both the cases I have in the increasing result. And then here the velocity profile for various values of rotation parameters are presented in this figure. The velocity decreases with an increasing the rotation of the entire system. It's a reverse order trending. The velocity profile initially remains parallel parabolically for a small values of the rotation parameter with the maximum at the entire channel, and then an rotation increases the velocity of the profile. And just conclusion, an oscillatory hydrodynamic convection flow of a viscous, incompressible, and electrical conducting fluid in a vertical porous channel is investigated when the entire system consisting of channel plates and the fluid rotates about an axis perpendicular to the plates. A closed form solution of the problem is obtained. However, the velocity decreases with an increasing in the rotating parameter, viscoelastic parameter, permeability of the porous medium, Prandtl number, and radiation parameter. Actually, due to the time duration, I just quoted some few graphs only here, sir. I would like to extend the paper after this presentation also. I would like to add more terms also, sir. These are my references which I have quoted here. That's also.
In these two papers, you have done, I think, closed form solution related with perturbation, right? For both papers, or in second
Yes.
paper? Only in the second. Both
Yes.
papers.
Yes.
Okay.
Yes, sir.
So have you compared
No,
it
sir. First paper.
only then second paper?
Yes, sir. Actually, first paper almost over, sir. If I need, I can add some soret and some other effects, sir.
No, I'm
Second
not.
paper, I would like to add some more terms and.
Okay.
Yes,
I'm
sir.
not asking about effects or extensions. I just asked about methodology. Methodology, first work and second work, both you have solved with using perturbation. Am I right? Like analytically, to get
Yes, sir.
close.
Both using both are retribution technique only, sir.
Okay, so have you compared these closed form solutions in anywhere in earlier results with which you have already published, or otherwise did you try
No,
to
sir. This
compare
is.
numerically?
So first paper, I will try, sir. In my second paper, this is my first paper by using the second order fluids.
So
So now only I have to
then how we can validate that your results are
not a
right?
com
Yeah, how we can validate your results are right throughout in this paper? Suppose we can be able to solve anything, but how we can validate that results are right? We need to compare it somewhere
so by
using other methodology, or otherwise
yes,
earlier results, published results, right? So that
sure,
and
sir. We
try,
will try
yeah,
to use some. Sure,
please
sir.
make
Sure,
a
sir.
note
We'll
of
use,
this
sir.
and try to
We'll try
use
to
the
solve this first.
okay,
Sure, sir. I will try
note
some
of this.
numerical technique also, sir.
Okay, okay. So make a note of this and
Okay, sir.
try to
Okay,
use
sir.
numerical technique or otherwise already published works comparison, so that the reader can assure or otherwise thinking more about your paper that is right or wrong. Okay,
Sure, sir. I will try to use the Ranjikuta method and some numerical new techniques also, sir. I will try to learn some things, sir.
okay, okay, fine, fine. Okay,
Okay, sir. Sure, sir. Thank you, sir.
yeah, sir. Uh,
No, I also had the same question regarding the validation. So, sir has already suggested you that what should you do? Try to validate your results whenever you are giving some plots. That means you are going into that numerical part. So, not only that analytical extension or not only the analytical things. So, whenever you are presenting something numerically, either go for some some convergence analysis or error analysis or something like that, or some validation with already published result, so that in that way someone
Sure.
can some readers can assume that your results are correct up to some certain. So that's all. That's all. That's the suggestion from our side. So anyway, good presentation. Thank you.
Okay, sir. Thank you, sir. Surely I follow your instructions and proceed my other results. Thank you so much.
Okay.
Okay, sir.
You can leave. Thank you.
Okay, sir.
Next candidate Raj Gayatri. Raj Gayatri.
Yes, sir.
Yeah.
I'm,
First
shall I share my PPT, sir?
introduce yourself and then come to the presentation.
Yes, sir. I am Raj Gayatri, doing my full-time scholar in SRM University. Shall I share my PPT,
Yeah,
sir?
you can start.
Sir, just a minute, sir. Some problems.
Raj Gayatri, am I audible to you?
Sir, 1 minute, sir. 1 minute, sir.
Are
Sorry,
you
sir.
trying to show it in screen from mobile?
Yes, sir.
Okay, from mobile means you first make your rotation screen off. It's already
Oh,
in lock on, so you remove that lock off. Then only it will. Now it's fine.
okay, sir.
ಇಲ್ಲ ನೀ stop sharing.
Now it's clear, sir. Okay,
Clear,
sir.
no problem.
Um, My title is Analyzing the Effects of Chemical Reaction with Heat and Mass Transfer on L-shaped porous medium using perturbation technique. Abstract. This article is an extension to the heat and mass transfer in L-shaped porous medium by including the mass diffusion. The heat and mass transfer with chemical reaction of the fluid in L-shaped porous surface is considered here. The equation of the fluid represented by three partial differential equation representing the velocity, temperature and concentration of the fluid. Using perturbation technique, solving the three partial differential equation and finding the solutions. The fluid's velocity, temperature, and concentrations are analyzed for different parameters through graph. These are these are my keywords. Introduction: heat and mass transfer in porous media with respect to various geometry has been reported in literature, but still there is a scope for further research in uncommon geometrical shapes such as L shape. The heat transfer and its effect on various phenomena can be found, and that can be described the various phenomena coupled with different geometries. To the best of author's knowledge, heat and mass transfer in L-shaped porous region has not been reported, thus motivating us to carry on this investigation. This is my diagram. L-shaped porous medium. L-shaped porous medium is considered as shown in that figure. The heat and mass transfer in such system can be described with the help of momentum equation, energy transport equation, and mass diffusion equation as given below. These are these equations. The above equations should be solved with suitable method to find the values of solution variables such as temperature, which is in first equation, and the steam function in the second equation, and the concentration distribution inside the porous medium. Finite element method has been utilized in this study to solve equation 1, 2, and 3 with the boundary conditions, which is shown in the first figure. It should be noted that the solution of the equation is obtainable in hydrative manner due to multiple solution variables which are coupled together. This is the graph. In column wise, the the variables values at n is 0, whereas in second column the variable value for n is 1. For A it is isotherms, and for B it is isoconcentration, and for C it is streamlines. Result: the hydrative solution of governing equation yielded the value of each of the solution variable at every node in the domain. These values are further proceed to understand the heat and mass transfer characteristics inside the porous medium by plotting the contrast of temperature, stream function, and concentration. It is found that the isotherms have not much affected due to change in Bioran's waste ratio. However, the concentration line distribution reaches far deep into porous region. It is noted that that mass diffusion is restricted to only horizontal leg of L shape. The concentration lines gets affected considerably due to the change in Lewis number, but there was not much of its effect on isotherms. The fluid is found to have two cells at lower Lewis number as compared to its higher value. Conclusion: here I concluded that the heat and mass transfer in L shape is found to follow similar trends as in other geometrical shape of porous medium, and another is the mass diffusion is restricted to only horizontal leg of L shape porous region with no concentration lines in the vertical leg. These are my references.
Radhika, I think very nice presentation.
Thank you, sir.
Okay, so go to the equations, governing equation part.
Uh,
Yeah,
I
governing.
want to.
Yeah,
Yes,
yeah.
sir.
Scroll up after governing.
Yes, sir.
So here you wrote psi bar, psi. So what it represents psi? Usually we will have a velocity like u and v. What it represents psi, and why you how you converted that u and v, both the velocity u direction, and that means horizontal direction and vertical direction in terms of psi. What does that mean of psi bar?
Uh, Xi.
Is a
Heat represents the heat transfer, sir.
Okay, that is T, but what is that
Okay.
Xi? Xi.
Uh, it a chemical reaction, sir.
Then what is mean by C?
Sorry, sir. See only chemical reaction.
So Xi means
Uh, mass transfer, sir.
stream function. Okay. So Xi is a
Okay.
stream function. We are just making
Okay.
the velocity, horizontal velocity and vertical velocity to be in the form of stream function by using the equations, which will be available in already in MSc studies itself. Like
Okay,
U
sir.
is equal
Okay.
to dou xi by dou y and like dou minus dou xi by dou y and b equal to dou xi by dou x. So those
Okay,
equations.
sir. Okay, sir. Okay, sir.
Okay. Sir, so big sir.
Uh, Subject wise, I'll not say anything. It's like your presentation was compact. Only thing I will suggest that whenever you are presenting, just keep less things or less lines in your slides, because that is somehow is not good for the presentation. Means your presentation was compact within the time period you have finished, so that's good. But
Okay, sir.
from next time onwards, just try to keep less things, only the equations or bullet wise the points you have to remember during your presentation, so that
Okay,
you can
sir.
mention in your slides. The only
Okay, sir.
suggestion is there from my side. Okay,
Okay, sir.
thank you.
Thank you, sir. Next time I have corrected this mistake, sir.
Okay, okay, okay.
Thank you, sir.
Okay, you can stop here.
Okay, sir.
Rohit, Rohit, are you there? Rohit, sir. Uh, Padma ma'am student. Chandrila, Chandrila, are you there? Jisha,
हाँ
Jisha,
सर आई एम हियर
yeah, you can start. Introduce yourself and start.
सर आई एम ऑडिबल हेलो
Yeah, you are audible. Your voice is getting break. Am I audible to you? Fine, fine, now fine. Jisha, am I audible properly to you without any breaking? Jisha, your voice is getting break for each and every second. Am I audible to you properly now? Would you able to hear without any distraction? Jisha,
divided motivation and aim scope introduction some result and numerical example
Jisha, your voice is getting break for each and every second. Could you able to hear me? Jisha? Contact her in phone.
Okay, sir. Non-conservation law.
Prakash.
Sir, we can. Yes, sir.
Prakash. Jisha ஏதோ ப்ராப்ளம் போல இருக்கு. ஜிஷா ஏதோ ப்ராப்ளம் போல இருக்கு. நெக்ஸ்ட் கேண்டிடேட் கூப்பிட்டுருங்க, அப்புறமா டைம் கொடுங்க. ஓகே ஓகே. அவர் சோவி கொண்டு இருக்காரா? சோவி கொண்டு, கேன் யூ ஷோ யுவர் ஃபேஸ்?
Yes, sir. Sure.
Okay, okay, okay. It is always better to have the video so that there will not be any issues.
Okay.
How many talks are over in your session now?
Totally 3 talks are over.
Yes. This was the 4th talk, but
Okay, okay. You please continue. Continue.
Okay, sir.
Whenever any candidate is having issue network problem, you please give them extra time.
okay.
In between, you need not wait. Call the other person to give the talk.
Okay. Okay.
Yes, sir.
Okay,
Shall I
okay. Please
continue?
continue.
Okay, sir.
Thank you.
Okay.
Jisa, you can continue.
Okay, thank you, sir.
First, start to present your screen. Present your screen, then give a present. Be able to present?
Sir, now it's audible.
Audible, it's fine, but no.
PPT is visible.
Yeah, no PPT is visible. Look in the right down, present now option will be there. So click it and then present the entire screen so that it will come. After clicking present now, present entire screen will be visible. Click
Sir, that only I'm doing, but share option not coming.
Will come obviously. Are you using a laptop or mobile?
Laptop.
You click present now. Your entire screen is
Present.
visible or not? There will be 3 tabs. Your entire screen.
Your entire screen only I clicked, sir, but it's not coming.
After clicking it, once again it will ask. So click share your entire screen. Then once again
But
you
share
click
option
it.
not coming. It's cancel only it's showing.
No. First you click inside also. Now it's fine. Yeah, now only it is coming. Did you find where you did mistake?
I think some other person trying to share.
Daisy Juice.
Okay, sir, I already
Okay,
share
okay.
PPT for her.
She is opening it and she will use it.
Just now I'll share your PDF. We'll continue with your presentation.
Okay. Okay, I will try Daisy. Hello. Hello.
Yeah.
Okay. Shall I start, sir?
Yeah, you can start.
Okay. I am going to present a survey of non-conservative formulation for convection diffusion and hyperbolic problem. Next slide, please. This talk divided into 6 part: motivation, aim and scope, introduction and main result. Last numerical discuss result we explain. Next slide, please. This is the one this one of the application in non-conservative PDE. This is a tailing discharge from pipeline. And next slide, please. This is the tsunami wave. This is also corresponding PDE, also non-conservative form. Next slide, please. This is a supernova. This is also one example of non-conservative PDE. Next slide. My aim, the lack of conservation property imposes several challenges to solve PDE. It is well known that the theory of distribution in non-conservative equation can make no sense. So in this non-conservative partial differential equation, non-conservative product play an important role. My major focal point of this work is to give a brief introduction to numerical scheme and method for non-conservative form of hyperbolic PDE. Next slide. The major difference between conservative and non-conservative equation is conservative equation, the variables are conservative form. For example, for Berger equation, we will consider dou t u, dou x, fu equal to 0. If you use the Berger equation, then flux function is u square by 2. But if it is non-conservative, we cannot write this form. So we can write only u into dou x u. Next slide, please. The main contribution to this field, the main result of the theory is Dalmazzo and Leifrock for non-conservative product. Next slide. Non-conservative hyperbolic PDE, previously we discussed. So non-conservative hyperbolic PDE equation contain non-conservative product. So that form dou t plus a of u into dou x u equal to 0. The essential product feature of the non-conservative product is a does not equal to df, means we cannot write in a differential form. And A is the Jacobian matrix of the flux function. Discuss problem once the solution becomes discontinuous. Because the weak solution in the classical sense of distribution then does not exist. This is the main challenges in this field. Non-conservative product. This is the main result in this area. So we consider some example. U of x equal to ul plus h into x minus xd ur minus ul. H is the Heaviside function. If at a discontinuity, one's value is 0 and other value is 1. For this is a discontinuous function. And if you take g is a smooth function, then also g of u into dou x u is not defined, because this derivative will going to infinity. Next slide. Non-conservative product we cannot define for directly for discontinuous function. So we need one approximate solution. We consider a regularization of u, that is u epsilon, and we taking the total variation for that sequence. Then we will get g of u into du dx equal to limit epsilon tends to 0 g of u epsilon into d epsilon by dx. This is a non-conservative product. As a it is a bounded measure in radon measure space, and the limit of the regularization on non-conservative product depend in general on the path in the regularization. Next slide, please. This is the main result in this area. DLM theory. Dalmazzo, Leifrock, and Murray provide in general theory for non-conservative PDE. This is the here main result they will taking according to path. We want to solve non-conservative problem, but one approach is according to a path they will solve. So for that they need a Lipschitz continuous path. Phi is the function 0, 1 cross Rm to Rm, and phi of 0 ul ur equal to ul, and phi of 1 ul ur equal to ur. That means it is connecting path between ul and ur. And at ul it's exact value. And last S3 condition is for Lipschitz continuous. Next slide, please. This is the main theorem, one another main theorem, and U is the open interval AB to R raised to M is a function. It's a bounded variation, and this is a continuous function. Then there exists a unique real valued Borel measure U, and mu of B equal to G of U into du by dx. If suppose U is discontinuous, then this will converted into 0 to 1 G of phi of tau UL UR dou phi by dou tau into tau into UL UR d tau. Tau means it belongs to AB. By definition, this is a measure, and this is the non-conservative product. Mu is the non-conservative, and it is conservative product, and it's a measure. It's a defined G of U into du by dx. For discontinuous case only, we define the path function phi. Next slide, please. This is the path concept. And next slide. This previously we defined the path function. How do we define the theoretical difficulty depend to discretization of non-conservative framework. So that's why we are using path. But the first challenges in this area is how to we choose correct path. This is a very big miss problem in this area. This is the gem condition. If it is conservative, then it will satisfy the gem condition psi of U equal to f of U. It's for earth equation. Next slide. This is one example of degenerate convection diffusion equation. This diffusion term is a non-conservative form. So k of U into us. That is a non-conservative form, and it's a degenerate equation. As a consequence of degeneracy of the viscous term, the system may have the solution, the present shock discontinuity due to the hyperbolic and parabolic dynamic of the problem. That means if the k tends to 0, it will convert it into hyperbolic problem. So we know hyperbolic conservation law have so much difficulty to solving it. Next slide, please. These are some results already done. The uniqueness and stability of the entropy solution of degenerate convection diffusion. It's introduced by Arsling, and some result. This is the numerical result. This Berger equation we consider, and KUX is the non-conservative and conservative form we consider. And next slide. Next slide, please. For scheme we consider, first flux function is entropy conservative, and the discretization source term also conservative. Second scheme we consider entropy conservative and a non-conservative discretization of source term. Third scheme we consider, third and fourth we consider some extra diffusion adding, because if you have any discontinuity in initial solution or some non-linearity in flux function, then it will k tends to 0, it will be hyperbolic nature. That time near discontinuity oscillation will happen. So we want to reduce the oscillation, so that's why we are adding the extra diffusion. That is the scheme ES3 and ESC4. Next slide. This is the example of with the Berger equation. This is for continuous data. Next slide. With a mu equal to 0.1 that time choose, so that's why we will not get any oscillation. And from this we can understand that EC4 is a non-conservative form, and EC1 EC2 is the conservative. But if you from figure we can understand the EC4 is more approximate, and EC1 also. Next slide. If mu equal to 0, then oscillation will come. It will be hyperbolic nature. That's why near in between 0 and 1, some oscillation is showing. So in this case, some shock will develop, and some oscillation will come. So we adding extra diffusion, it will overcome and it will reduce it. But if we are using higher order method, that is not a easy purpose, because sometime oscillation will come, but sometime the accuracy will reduce it. So both will maintain. It is very difficult challenge. And next problem. Next slide. This is also one example. If you this time 0.5 equal to t equal to 0.5, smooth initial data we consider. Next slide. This is a summary. This one of the main building block of non-conservative theory formation is constructed by Dalmalso and Leaflock. And in non-conservative formation, two type theory is there. One is approach is full depend on path, and next is it does not depend on path. The main problem of the non-conservative form is that the numerical solution does not converges to physically relevant solution, and it converges some other solution. Here path concept is introduced, but finding a suitable path is very difficult job. Next slide. At the beginning of the 19th century, some work and research some finite difference method they introduced. After that, in 20th century, the Galerkin method, the finite difference Galerkin method, they used to solve this type of PDE. Next slide, please. Next slide, please. The researcher Castro and Carlos' contribution is much of the theory is related to higher order entropy non-conservative scheme. Castro introduced the measure-valued framework of the non-conservative form using Lebesgue decomposition theorem, which is also related to the path concept. And one of the main challenges of this field, how to find out a suitable path. Otherwise, we need introduce a new approaches that does not depend on path. This is our future work. Next slide, please. This is the conclusion. Actually, it is a survey work. The main aim of this survey is to give a short introduction to the non-conservative formulation. Whoever newly work in this area, we believe that it is a kind of an introduction to the beginner on this topic, non-conservative form. Thank you. Thank you, sir.
Nice presentation, but it should be in compact.
These are the some reference.
No, it's okay. I also don't have any question. Nice presentation and lots of things covered. So, okay.
Thank you, sir.
On to the next candidate now. Tirupura Sundari. Tirupura Sundari. Tirupura Sundari. Tirupura Sundari. Then Sangeeta. Sangeeta. Tripura Sundari, are you there? The meeting? Okay, Rajesh, are you ready? So in the list, Tirupura Sundari, Sandrila, Rohit? Rohit, are you there? Rajesh, you can
Okay, sir.
present your screen and introduce yourself.
Just a second. Show ಆಗುದಾ? Hello. Hello.
Audible. Present your screen.
Just a minute, sir. Sir? Hello, sir. I'm K. Rajesh. I'm doing full-time research scholar under the guidance of Dr. A. Govindarajan, Professor and Head. My topic is about oscillatory flow through porous medium in a rotating vertical channel with chemical reaction, radiation, and thermoconvection. My abstract is about in this present paper an atom has.
Rajesh,
Yes, sir.
you have not started a presentation so far.
Just a minute. Can you able to see my PPT, sir? No?
Please visible.
I can't hear you, sir. Hello.
Yeah, it's fine now. Your
Okay, sir.
PPT is visible.
Okay, I'm K. Rajesh, doing full-time research scholar under the guidance of Dr. A. Govindarajan, Professor and HOD. My topic is about oscillatory flow through porous medium in a rotating vertical channel with chemical radiation and thermoconvection. My abstract is about this paper present as attempt has been made to study the oscillatory flow through porous medium in a rotating vertical channel with chemical radiation and thermoconvection. The problem is solved analytically and the expressions for the velocity, temperature, concentration, spin friction, and the rate of heat and mass transfer are derived and the effects of various physical parameters like magnetic parameter, radiation parameter, Grashof number, Prandtl number, permeability parameter, and the chemical radiation parameter are studied through graph and tables. The whole system rotates with the uniform angular velocity around this axis normal to the plate planes. The significance of the steady and unsteady resulting velocities as well the phase difference on different parameters is investigated in detail for small and large rotations. So this is my mathematical analysis. Uh, these equations has been considered in my continuity equation, momentum equations, energy equations, mass concentration equations. So these are seeing these equations, I will get my velocity, temperature, and concentration results. So this is my graph. The effect of Schmidt number on concentration species profile. The concentration profile increase due to an increase in Schmidt number. The concentration profile, the species concentration profile increases with an increases in injection and suction parameters. So this is my cross flow velocity profile. So my conclusion is the effect of injection section parameter modified Grashof number for mass transfer, Schmidt number, and permeability parameter on main flow velocity profiles and skin friction in the main flow direction are same. The injection fraction parameter and the permeability parameter to have got the influence of increased main flow velocity profile, species concentration, and skin friction in the main flow direction, whereas they have got an opposite influence on skin friction in gas flow direction and heat transfer coefficient. Modified Grashof number GM and Smith number SC shown a significant increases in the profile of main velocity, skin friction in main direction, and the species concentration. So this is my conclusion. This is my next topic: chemical radiation and chemical reaction and the radiation effect on MHD flow through porous medium under oscillation section with a thermodiffusion. Actually, this is my extension paper of first paper. I included here chemical reaction and the MHD. That's all, sir. Thank you.
Savik, sir.
Uh, it's okay. No such questions are there. Good presentation, I must say.
Thank you, sir.
So, he has another.
Okay. So now, Tripura Sundari, are you there? Tripura Sundari, Chandrila, Tripura Sundari, Chandrila, Rohit. So we'll wait for our next candidate. He is trying to join. Comes in.